This video goes through one more example of a stoichiometry problem. So in this problem, we're passing chlorine gas through molten sulfur and producing liquid disulfur dichloride. And we're asked how many molecules of chlorine react to produce 50.0 grams of disulfur dichloride. So remember, first step is we always need a balanced chemical equation. So we've got chlorine gas reacting with molten sulfur to produce disulfur dichloride. Balancing this, we just need a 2 then in front of the sulfur. Okay, so balanced chemical equation taken care of. Our second step is we're going to convert our known value to moles if required. So it is required here because it's given to us in mass. So the moles of disulfur dichloride is our mass divided by our molar mass. We're given 50.0 grams, and the molar mass of disulfur dichloride is 135.04 grams per mole. And that would give us 0.3702 moles of disulfur dichloride. Step 3 then is setting up our mole ratio. So we know from our balanced chemical equation that, what are we looking for here? We're looking for moles of chlorine, and we're given mass of disulfur dichloride. So for every 1 mole of chlorine gas that reacts, we produce 1 mole of disulfur dichloride. So 1 mole of Cl2 produces 1 mole of S2Cl2. We're given, we're trying to find the number of moles of Cl2, and we're given 0.3702 moles of S2Cl2. Okay. So solving for this, because it's a 1-to-1 ratio, the moles of Cl2 that react are the same as the moles of S2Cl2 that are produced. If you recognize this and you don't want to write out this whole mole ratio, you could just say that it's a 1-to-1 ratio, and then just say therefore the moles of Cl2 is equal to, and give me the answer here. So this is totally acceptable for this sort of question as well. Finally, what we want to do is convert the number of moles of our unknown value to the units required by the question. Now the question is asking us for the number of molecules of Cl2 that react. So we have to remember that the number of molecules of Cl2 is calculated by taking the number of moles of Cl2 and multiplying it by Avogadro's number. We're going to take 0.3702 moles and multiply it by 6.02 times 10 to the 23, and that would give us, to significant digits we need 3, so 2.23 times 10 to the 23 molecules. And that is molecules of Cl2 that react. Okay. So sometimes questions will give you molecules instead of a mass, or it'll ask you to calculate molecules instead of a mass. It's the same process, just a different formula that we need to use when we find the number of molecules.